All right, so I'm going to talk about a piece of work that we did a few months ago called Challenges with Unsupervised Language Model Knowledge Discovery. This was work done with all of these wonderful colleagues at DeepMind. So the first question is, why would you want to discover knowledge at all? Why not ask the model what it knows? And this is, I guess, been covered by a few speakers before as well. But the main problem is that we might train models for performance on something and not fully understand how they're getting that high performance. And we could try to ask them how they're getting their high performance, and we would get some answers. And we would like other ways of telling whether the answers are good, apart from relying on the model's outputs. And there are reasons why the model might not be entirely forthcoming about the reasons that it's giving to us. So why do unsupervised discovery of knowledge? So the main problem is that we don't have labels for the cases that we're actually interested in, where the risk is higher. And this is because as our AI systems get stronger, it's easier for us to measure their performance on some task than it is for us to know the reasons why they're doing those tasks. And so if you don't have labels for those things, then our methods to extract knowledge are sort of need to be unsupervised, or we need unsupervised ways of checking the reasons that the model's giving. So one strategy you could have for trying to extract reasons in an unsupervised method is to do consistency checks. And here's an example of doing this. So you might observe that if something's true, then it should satisfy this kind of negation consistency. And so you might try to employ the strategy of searching for ways of extracting knowledge from the model that satisfy this consistency. And so here's a piece of work from OpenAI, from Colin Burns and colleagues, that tries to use this strategy. So there's quite a lot on the slide, but I just want to focus on the are cats mammals question. And the way this works is you give the model this question, and then you append a prompt. You append this word yes or no at the end of that question. And you look at the internal activations of the model, right? So you're not relying on the model's outputs at all. You're just doing white box access into the internals. And then you can try to cluster the internal activations based on a full data set of these kinds of contrast pairs, and then search for directions that kind of maximally separate these two clusters. And if you do this, it turns out that you can get some promising results that show that in an unsupervised fashion, you discover a direction that corresponds to whether the model thinks the question was yes or no. So we were initially pretty optimistic about this kind of approach, and then we started looking into it a bit more and came up with a number of examples where it seemed like this method was much worse than we initially thought. And I think these examples are kind of illustrative of some of the problems of unsupervised discovery methods like this. So here's an example of classifying movie sentiment. So ordinarily, you wouldn't have the Alice thinks it is. So normally you would just have the review, and then the model, and then you'd say like this review is positive or negative. So that's how you would construct the contrast pair. But you can insert this distracting feature about this kind of unrelated character, Alice, who also happens to have an opinion on the movie review, which is completely uncorrelated from the actual sentiment of the movie review. And you can run this experiment and check whether the unsupervised probe picks up on the sentiment or whether it picks up on this distractor opinion. And it turns out that sorry, what is the wave? I have a minute. Okay. So it turns out the distracting feature is much more prominent for methods like CCS and contrast pairs, which you can see from the much more separated clustering on the right-hand side here. This is another example that I quite like. which is this data set where you're trying to classify the topic of some entity. So for example, Phase is an audio company, and then the choices are, is this opinion about a company or about an animal? And we insert this distracting character called Alice, who is an anti-capitalist who will just never answer correctly about companies, but will answer every other topic correctly. And it turns out that about half of the probes that you would train using something like CCS on this kind of data set would learn the kind of anti-capitalist feature corresponding to Alice rather than the truth feature. So in conclusion, there's a number of challenges with unsupervised knowledge discovery. The main challenge we point out in the paper is that you can search for features that satisfy these consistency properties, but many features satisfy them, not just what we think of as truth. And then how do we go beyond consistency? So can we use, for example, mechinterp to look for features that are represented structurally differently and try to find differences between truth and other things? And yeah, we also highlight a number of more speculative outcomes. So check out our paper.